Have you just got your first 3D printer? In this video, I'll take you through assembly, a tour, and how to do your first prints. So you've just got your first 3D printer and you're really excited about the possibilities, but maybe you're not quite so sure where to start. This video aims to be your companion on how to assemble the printer, learn what all of the parts do, and then do your first prints. The printer I have here is the Ender 3. It's the perfect gateway printer to get people into the hobby. It's relatively inexpensive and it's got great performance out of the box. They're not all perfect, however, so in this video we'll look for some areas to check to avoid disaster. If you're following along on a printer besides this, don't worry, I'm going to cover lots of general principles, so let's get started by unboxing and assembling this thing. The first thing you should do is look for any signs of major damage on the packaging. This one has a couple of tiny blemishes, but overall I think it's okay. If yours is in worse condition, you might consider taking photos as proof in case there's something wrong inside. Now, as you're pulling everything out, most of the components should be pretty obvious, but just take care to check for anything that might be hidden inside pockets in foam, even on the underside of the large flat pieces. So I've laid out all of the parts in front of me and moved some of the tools and manuals that we'll need later on over to the side. It may seem a little bit daunting at first, but generally the instructions on these 3D printers are quite well developed, and apart from a little bit of broken English, relatively easy to follow if you're mechanically minded. It might be a good idea to go to the assembly list and make sure you have all of the parts that are meant to be in the box. Once you've verified that, move on to step 1, building it like Lego, pulling out the parts that you need beforehand and then studying the diagrams to put everything together. Here's a really important step that you don't want to miss. You need to correctly set your voltage depending on the part of the world that you live. In Australia, I need it set to 230 volts. The final satisfying step is to peel off this protective film. Unfortunately, the knob for my printer was missing, but I guess that's something I can print later on. So our printer is completely together and you're probably excited and want to turn it on and get started. But before we do that, we're going to go over the machine, looking at what all the different parts do and check out what bits we need to tighten and tension to make sure it runs correctly. First things first, we need to check the tightness of the bolts around the printer. The ones that we put in, we know they're tight, but it's worth spending around 2 minutes moving around the machine, making sure the rest are tight as well. We'll start our tour of the 3D printer with this here. This is the power supply. Our mains voltage comes in from the wall. Remember, mains voltage is the one that can kill you. And the job of this component here is to transform it down to 24 volts direct current. The output of that then comes through this plug and into the main board under here. You can't see it straight away on the inside, but in there is the main board. This is the brain of the 3D printer. We have terminals for power coming in and then out for heated beds and the hot end. We have connectors for all of our end stops. We have connectors for our stepper motors, a connector that goes to the LCD, USB connector, and SD card. And in the middle is a microcontroller. That's the actual brain that holds the firmware and runs the printer. This ribbon cable coming out of the main board goes to the LCD. This is our main user interface if we're not connected to a computer. From here we can manually move around the machine, heat it up, cool it down, and start prints. The motion for our 3D printer comes from stepper motors. We have one on the side that turns to lift the Z axis up and down. We have one at the back that turns to move the Y axis back and forth. One on the upper end, and that controls the X axis. And our final one controls the extruder, which grips the plastic filament and feeds it towards the hot end. A quick note on these, like any other motor, if you turn them manually, they will generate electricity, which if spiking high enough can destroy your main board. So if you do need to manually move your printer, make sure you do it nice and slowly. This printer, like a lot of other modern printers, runs on aluminium extrusion. This stuff here is called 2020 V slot because it's 20 by 20 millimeters and the inside trench is in the shape of a V. All of our linear motion comes from these V rollers. As you can see, the wheels ride in the V trench, but this is definitely something to check to make sure they're tensioned the correct amount. With your tools should be a little spanner, and you'll find for each set of these wheels that one of them has a hexagon at the base. For each set of rollers, you should give them a wobble and make adjustments if necessary. This one here is actually pretty perfect, but I'll turn the hex nut, loosen it off, and you can see the problem we're checking for. You can see here I've loosened this off too much, and that increases the distance between the wheels, which means it's clamping less on the 2020 extrusion and therefore introducing wobble. If you have any perceivable wobble, just take your spanner and turn the hex nut until everything tightens up. By the same token, you don't want it to be too tight because you'll introduce premature wear on these rollers. Another motion system you might see are polished rods with linear bearings. They don't need any adjustment, but sometimes they can fill up with dust. Connecting the stepper motors to the carriages that move with the rollers are these belts, and it's extremely important that they're tensioned correctly if you want to have decent print quality. Now this wire one came tensioned pretty nicely. You can feel that it's got a bit of spring and it's quite taut, but for the X-axis, I've purposely left it floppy to show you how to tension it. On one end of the belts on most 3D printers, you should have something that you can loosen to act as a tensioner. Our job is to now pull this as tight as possible, and we can see the belt has become a lot more taut before we tighten it back up with our Allen key. At the end position for each axis is one of these. This is a micro switch used as an end stop. The printer could be in any position when it's turned on, so to help it determine its coordinates, it will home back towards these switches and know that it's now at 0. Let's talk more about the extruder. The job of this is to grip the plastic filament and force it towards the hot end where it's melted and then extruded to make up 3D prints. You can see we have a sprung arm, and the spring pushes the pressure between these two so this can have grip and push the filament through. We can't load the filament yet until we heat up the hot end, hot enough to melt the plastic, but we can show the initial loading. We squeeze, place through the hole, and guide it down into this here. This is PTFE tube, because this printer is a Bowden tube, where the extruder is separate from the hot end, but on some printers we call them direct drive because it's directly on top, with a minimal length in between. On the other end of the PTFE tube is the hot end, and I've disassembled mine to show you inside. The actual heater block is down the bottom here, and underneath the nozzle where the plastic comes out. This portion here is a heat sink. It's cooled by the fan on the front, and that stops the heat from spreading up here, melting the plastic prematurely and causing a clog. The other thing we have here on the side is a part cooling fan, which when everything is back in place, blows across the bottom of the nozzle to cool the plastic as it's extruded. Finally, we have the bed. This is the platform on which our 3D print is built up. The bed has a heater inbuilt, as well as a thermistor for measuring the temperature, and the top has a special surface to help our filament stick. With our tour and final tightening out of the way, it's time to turn the printer on. You'll instantly hear there's cooling fans to keep the electronics cool, as well as one in the power supply to stop it from overheating too. Some 3D printers have touchscreens, but the information displayed is pretty much the same. We have the temperature for our hot end or nozzle, the temperature of our heated bed, whether or not the part cooling fan is on, our coordinates for X, Y, and Z. The FR here stands for feed rate, which is the speed at which the printer moves. We have a bar that will fill up with a timer for when we're 3D printing from the SD card, as well as a percentage to match that. And finally, the lower line gives us feedback and messages. To use the menu, we click in to select, and then turn to scroll up and down. The main menu that you'll use is the prepare menu. In here, we can manually move our axes around. We can also auto home the printer. And now the printer knows it's at 0, 0, 0 coordinates. Other useful features include disabling steppers, so you can manually move the printer around, but most importantly, preheating the nozzle and bed, which you need to do before loading any filament. Now these mini rolls that come with the printer aren't very useful and they're prone to getting jammed, but they'll see us through our first couple of test prints. Now that the nozzle's up to temperature, we can once again squeeze this lever and feed the plastic manually through until we feel a little bit of resistance. From that point, we can push through and we'll probably feel and hear that it's coming through the nozzle. Obviously, the underside of here is almost 200 degrees, so you should be very careful when handling it, but we can remove the filament and back on the LCD, come to prepare, scroll to the bottom and go to cool down. Our printer is together, we've checked it over, and we've even loaded up filament, which means we're just about ready to print. There's two important steps that unfortunately aren't in this manual, so we're going to include those in this video. The first is setting up the software in our computer that processes 3D files for this to print, and the second is bed leveling, which is by far the #1 thing that trips up new users to 3D printing. We'll start by setting up the software with a file that's going to help us with bed leveling. Let's talk about 3D printer software by starting with something you're probably more familiar with, a 2D printer. On a 2D printer, we might have text, images, PDFs, it doesn't really matter. The key principle is that we need a driver to convert these files to a language the printer understands before the printer can do its thing and create a print. For 3D printing, the concept is similar, except of course we start with a 3-dimensional file. By far the most common of these is the STL, which stands for stereolithography. There are more file formats for 3D geometry, with others being OBJ and 3MF, but STL is by far the most common. So where do we get these STLs from? Firstly, there are online 3D file repositories, such as Thingiverse. Thingiverse has been around for a long time and has many 3D files. There's a good chance you'll find something interesting to print on here. Another very popular and similar type of site is My Mini Factory. It has some pay models, but for the most part, the files on here are free. You can of course create your own 3D files using something beginner friendly like Tinkercad. When you're ready, myself and a lot of other people on YouTube have great guides on how to design your own parts on Tinkercad. It's a great start before you graduate to something more popular like Onshape or Fusion 360. Wherever you get your 3D file from, like the 2D printer, we're going to need a piece of software in the middle to convert it to a language that the 3D printer understands, and this is called the slicer. It's called this because it slices up the 3D model into flat layers that are built up on top of each other to produce the final object. You can pay for slicing software, but by far the most popular free slicer is Cura by Ultimaker. And the reason it's so popular is because out of the box it supports a wide range of 3D printers. To add the Ender 3, we're going to come up to Settings, Printer, and then Add Printer. We'll click on Add a non-networked printer, and we can see Ultimaker is the default, but if we scroll down, there's a wide range of 3D printers. For this video, we're looking for Creality 3D, and then Ender 3. Pretty much all of the parameters of the printer are preset. The only thing I recommend changing on the Ender 3 is increasing the printer width and depth to 235, which if you measure with a ruler, it actually is. We can then click Next, and our printer profile is set up, and we can even see that it has the Ender logo with the bed matching our real life bed. Our first print is going to be one that helps us level the bed. There's plenty on Thingiverse, but for this video, I'll use one of my own. It's a simple X, and we click on Thing Files, and then click on the file name to download the STL. Back in Cura, we can add this STL by going to Open, selecting our file, and then that'll put it on our virtual print bed. Our object is shown in yellow, and if we click on it, we'll see a toolbar appears on the side where we can move it, scale it, and rotate it as we see fit. On the upper right hand side, we have the settings for our actual print. If you're starting out, a lot of this is going to be overwhelming at this point, so just stick to the preset profiles. And for this print, standard quality 0.2mm is going to be sufficient. We can now come down and click on Slice. And when that's done, we can click Preview. What we're seeing here is a preview of the plastic as it will be extruded line by line. And we can preview exactly what happens with this slider. We can see at the start, it's going to draw a skirt. All this does is an outline to make sure that the printer is primed in the nozzle by the time it gets to the main object. After this, for each layer, it's going to do the perimeters of the shape. As the name suggests, they're the outer lines that form the walls. After that, it's going to go back and do infill, which is going to fill in any remaining gaps until we have a solid layer. If you're happy with the preview, you can come down and click Save to Removable Drive, or if you're saving it elsewhere, the little drop down and Save to File. My file has been saved to the SD card that came with the printer, so I can eject it and head over to the printer to level the bed. With the slicer installed and configured, we're ready to attempt bed leveling. Like I said earlier, this is the most crucial aspect of setting up the printer and will trip up 90% of new users. We're going to do it in 2 phases. Firstly, with a piece of paper, getting it roughly in place, and then during a live test print where we make our final adjustments. On a 3D printer, we have our print head, which, unless there's something very wrong, should travel side to side in a straight line. To keep this example simple, we're just going to focus on the x-axis. We have 2 aims when we level or tram the bed. Firstly, we're trying to adjust the angle of the bed, not to get it parallel with the ground, but rather parallel with the plane that the print head travels on. Secondly, we're trying to get it the right distance from the nozzle so that the first layer is extruded with just the right amount of squish to help it stick to the bed. There's only one tool we need for this, and that is an ordinary piece of office paper. The other thing we need to do is preheat the bed to the temperature that we print mostly with, and for PLA, that's about 60 degrees Celsius. We'll enter the menu, come to Control, Temperature, Bed, and then scroll until we reach 60 degrees. Now that we're up to temperature, we can then home the machine. The next thing we'll do is disable the steppers, which lets us manually move around the printer. We'll come to Prepare and down to Disable Steppers. As you can see, we've got quite a big gap between the nozzle and the bed, and we need to get the nozzle just a paper width apart from the bed before we can print. The first thing to understand about this process is that these leveling wheels are in each corner of the bed, and turning them one way lifts the bed up and turning the other way lowers it down. So what I'm going to do is to move the nozzle and the bed to get it a little bit in from the corner, put my piece of paper in between, and then turn the dial to lift up the bed toward the nozzle. When it gets close, you can start moving the piece of paper back and forth. The aim is to have the nozzle close enough that the piece of paper just gets pinched. I've achieved that now, and there's just a little bit of friction in between them. I'm now going to move the nozzle over to the right hand side and repeat this process. Once again, I've got a little bit of friction, so I can move on to the next corner. Now that we've done it for each corner, it's a good idea to go back to the original corner and double check everything, as doing the other corners might have moved the original height, and therefore we should do all 4 corners again to double check. Basically, you should go around as many times as you need to until adjustment is no longer required to have that little bit of friction between the nozzle and the paper. With the first half of our technique out of the way, we can now come down and start our print. When everything's up to temperature, the printer will home again, draw an intro line down the side to help make sure there's plastic in the nozzle, and then our print will begin. Now that we're printing, the aim is to adjust the dials in each corner to get the right amount of squish between the nozzle and the bed. But what is the right amount of squish? Well, to help you learn, I've made this diagram, and we'll start with too far away. We can see on the left, the nozzle is too high, the plastic doesn't squish, and therefore there's gaps in between the individual extrusions. This is pretty obvious to see in my example. You can see gaps in between, and because it's not close enough, it's also peeling up from the bed. Now we'll have a look at what happens when you're too close. The plastic doesn't have enough room between the nozzle and the bed, squeezes out sideways, and that creates little vertical ridges that pop up. Hopefully this picture depicts the little ridges sticking up, and you can also feel them by running your finger over the top. When you're way too close, the filament will be so thin that it's translucent, and you're going to have a hard time removing this from the bed at the end. Back to the middle of our diagram when we get it just right. This is the Goldilocks zone, and the plastic is squished just enough that the individual extrusions overlap just a little bit. That means it'll be smooth to touch if you run your finger over. There's no gaps and no ridges. It's all about getting the right amount of squish to the bed and in between each individual line. We can see in this back corner that our filament has pretty much disappeared, so we're going to turn the knob to lower it down and move the bed a little bit further away. We have a similar problem, but not as bad in this corner here, so once again we'll make a slight adjustment. This front corner is pretty much perfect, so we'll leave that one as is. So assuming we know the right amount of squish, how can we explain this picture here, where on the one print we have sections that are too far, just right, and then too close? Well, this happens because many 3D printer beds are warped. When I place the ruler down, you can see a little bit of daylight under the middle and the piece of paper fits through, even though the ruler is touching the bed on the edges. When we were looking at our diagrams earlier, we were focusing on everything being ideal and flat. It's quite common for 3D printers to have a warped bed, however, and that makes it extremely hard to level them for large prints. On the high points, the nozzle will be too close, and in other portions, the nozzle will be too far away. There are plenty of modifications you can make to fix it. Just make sure you don't pull your hair out chasing perfection that isn't attainable. I recommend your first proper 3D print should be this 20mm calibration cube. It doesn't need much filament, it won't take long, and it will help you diagnose any mechanical issues. Once again, I'm going to leave it on standard quality, slice, preview, and now I can not only inspect the G-code for each layer, but I can change which layer I'm viewing from the side. You'll notice that for the top and bottom layers, the infill will be solid, but for all the layers in between, you'll have a mesh pattern, and you can change the density of this to increase strength or save time. Earlier we spoke about the type of language a 3D printer can understand, so if we open the file that's been created, we can see the G-code. There's a long list of G-code that our 3D printer can understand for many different features, but by far the most common is a linear movement. Perhaps you remember graphing XY coordinates back at school. Well, 3D printers work on the same system, except with a vertical Z axis as well as an extruder measurement. The majority of G-code is just telling the printer where to move next and how much plastic to extrude. If you've got your first layer dialed in correctly, this one should go down without any trouble, and you can be mesmerized by watching your 3D printer build up your object layer by layer until it's done. In a little bit over half an hour, our calibration cube will be finished and we can remove it from the bed. White filament is particularly good at hiding flaws, but there aren't many on this print. It's turned out really well, and that explains the popularity of these printers, although not perfect, offer tremendous performance for their budget price. Humble beginnings, but we've got a pretty good calibration cube to start our 3D printing journey. So the question is, where to from here? Well, another popular print that people like to do to test their printer is working properly is a 3D Benchy. It's free to download and it shows up a range of flaws that you can turn your attention to if need be. Next, you might want to learn and improve your slicer settings. I have some video guides to help you do just that, and there's also other channels like Chep, who regularly test new slicer settings and even release videos with free slicer profiles that you can import and use straight away. Finally, you might like to modify and improve your 3D printer. Some people like to leave them stock. Other people like me turn it into an additional part of the hobby and like to improve them gradually. Whatever side you sit on, both are acceptable and you should do whatever works best for you. One modification that I would absolutely recommend is updating to the latest firmware to make sure you have the latest safety features on your 3D printer. I've already got a guide on exactly how to do that, and I'll be creating a new, concise and easier to follow version in the near future. Hopefully, if you followed along with this video, you have a better understanding of the printer, its components, the software and files needed to operate it, and it can be the start of something really enjoyable for you. If you still have any questions, please leave them down below in the comments. Thank you so much for watching, and until next time, happy 3D printing. G'day, it's Michael again. If you liked the video, then please click like. If you want to see more content like this in future, click subscribe and make sure you click on the bell to receive every notification. If you really want to support the channel and see exclusive content, become a patron. Visit my Patreon page. See you next time.